In this video, we're covering a couple simple examples of questions that we can answer about transformers. So we're told we have a neon lamp requiring 2500 volts AC to run. We're plugging it into the wall, which is 120 volts AC. And in part A, we're going to get the required turns ratio. That's the number of turns in the secondary coil divided by the number of turns in the primary in order to step the voltage up to 2500 volts. And then in part B, we're going to get the current output given the current input into the transformer. And the solutions to both of these parts depend on simple formulas that were derived in another video. And I'll just post a link to that real quick. So to answer the first question, to get the turns ratio, we use our transformer formula that relates the voltage and the voltage out and the number of turns in each coil. And there it is. And just a reminder, the S stands for secondary, the P for primary. So the primary side is the side we're powering, and then the output of this thing is on the secondary side. Now what we're looking for is NS over NP, so we could just multiply both sides by NS to get that on the right-hand side in the numerator. And I'll go ahead and write that on the left, NS over NP. At the same time, we're dividing by VP on both sides, so we end up with VS over VP. And our output voltage is 2500, our input voltage is 120, and we arrive at a turns ratio of about 20.8. So we don't know how many turns are in the primary and the secondary, we just know there's about 21 times as many turns in the secondary coil. To answer the question about current output in part B, we use our second transformer equation relating current and the number of turns in the coils. So I have IsNs equals IpNp. And what we're looking for here is the secondary current, the current output. So that's Is. And we divide out the Ns to solve for that. So we expect the current that's coming out at the higher voltage to be a smaller current. This is a conservation of energy issue. That's actually where the formula came from. And Np over Ns, that's the reciprocal of that number that we just found, 20.8. So I'll just write 1 over 20.8 times our primary current, which was half an amp. And I get 0.0240 amps, just keeping 3 significant digits there. And I could call this 24.0 milliamps. And we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.